Worksheet number 2. Light wave is an example of, so light wave is an example what, children? Is it a longitudinal wave, transverse wave? It is an electromagnetic wave as well as a transverse wave, because I just now told you that all the radio waves, light waves come under the category of transverse wave. Okay. So, light wave, you know that light wave is an electromagnetic wave and also transverse wave. So, both 2 and 3 is true. Hence, light wave is an example of both 2 and 3. That is electromagnetic wave as well as transverse waves. Now, moving to the next question. The lowest part of the transverse wave below the line of the zero disturbance. So, this is the line of zero disturbance. Okay. So, if a wave is passing, a transverse wave is passing in this direction, all the upper cases are called as your crest, and the bottom below that transverse wave, zero disturbance is called as your troughs. Hence, the correct answer is option number 3, that is trough. So, now moving to the next question. Density distance graph. Okay. So, earlier when I explained the longitudinal waves, I plotted a diagram, children, where the horizontal line indicates that density and the vertical line indicated the distance or displacement. So, density distance graph represents which one, children? The density distance graph always represents a longitudinal wave. So, statement A, transverse waves can travel through solids only. Is that statement true, children? So, transverse waves cannot travel through solids. Statement B, longitudinal waves can travel through solids, liquids and gases. So, because we know the transverse waves can also travel through vacuum. So, what they said is only in the solids is a wrong statement. Statement B, longitudinal waves can travel through solids, liquids and gases. Of course, the statement B is true. So, which is the correct statement? Both are true, only one is true. Of course, statement B is true. So, second option is true. Well, moving to the next question. The speed of electromagnetic wave. The speed of electromagnetic wave is nothing but the light wave. So, light wave always travels with a speed of 3 into 10 power 8 meter per second. That is second option. So, now moving to the next question. Name the type of wave which is produced in air when tuning fork is struck in air. And so, tuning fork, children, tuning fork will be something like this. The structure of tuning forks, I hope you have ever seen in case of some laboratories and all. So, this is how a tuning fork looks like. Whenever these are called the prongs of a tuning fork, and this is the stem of the tuning fork. Whenever a tuning fork is struck with the help of a rubber hammer or some disturbance, okay, when some disturbance is created to the one of the prongs of a tuning fork, they start vibrating to and fro like this, like this, like this, like this, back and forth or to and fro. That means what type of waves are being produced in? Whenever it vibrates to and fro or back and forth, the type of waves that are produced in it is a longitudinal wave. Hence, it produces longitudinal wave. Second option is true. The waves produced inside the water is, I told you that transverse waves are always produced on the surface of the water, but not inside the surface of the water. But what they are asking is inside the water. Inside the water means it is a liquid. Water is a liquid. So, what type of what type of waves can travel through liquids? Obviously, longitudinal waves. So, which one is the correct option? So, question number 7. The correct answer is only longitudinal waves. So, here only longitudinal waves is the correct one. So, now moving to the next question, 8th one. In a wave motion, the particles oscillate perpendicular to the direction of wave propagation. Perpendicular vibrations. Which type of wave oscillates up and down or perpendicular to the direction of the wave propagation? Up and down means transverse wave. So, correct option is transverse wave. Up and down is transverse wave. To and fro is longitudinal wave. So, first option is true. Okay. So, now moving to the next question, 9th one. In a wave motion, the particles oscillate in the direction of wave propagation. So, wave is also traveling in one direction, the same direction that is parallel to the direction of propagation of the wave. The particles are oscillating. So, these type of particles that is parallel to and fro, back and forth, whatever you consider, they are of longitudinal waves. Hence, for the 9th question, second option, that is longitudinal waves is true. So, well, now moving to the next question, the waves in which crests and troughs are formed. I told you, children, alternate compressions and rarefactions are formed in the longitudinal waves, whereas the alternate troughs and crests are formed in the transverse waves. Hence, option number 2, that is transverse wave, is the right answer. So now moving to the next question number 11. Which wave does not require material medium for their propagation? So what type of wave can travel through vacuum as well? No medium, no solid, no liquid, no gases, but still the wave can travel. So what type of wave, children? Electromagnetic wave can even travel through vacuum. So does not require any material medium, is nothing but your electromagnetic wave. Mechanical waves require a material medium for their propagation, whereas electromagnetic wave do not require any material medium for their propagation. So first option is. So now moving to the next question, that is question number 12. Which of the following wave is a mechanical wave? Obviously sound wave, light wave, radio wave, microwave all come under the electromagnetic wave, whereas the sound wave is a mechanical wave. So option number 2 must be true. Well, moving to the 13th question, mechanical waves can travel through. Definitely for a mechanical wave to pass through we require a material medium. So mechanical waves can travel in a medium but not in a vacuum. Of course is the right answer. They cannot travel through vacuum. Wrong answer. Third is the wrong answer. Neither in vacuum nor in medium. Of course, mechanical waves travel through solids, liquids and gases but not in vacuum. Hence, they can travel through a medium but not in vacuum. First option is true. Well, the next question, the separation between two successive crests in a wave is a wavelength. Between two crests or between two troughs, the distance between any two crests or troughs is called as a wavelength, indicated with the letter lambda. Hence, 14th one, first option is true. What is the answer? Lambda. So now moving to the next question, that is 15th one. Waves formed on the water surface are. What are the waves formed on the water surface, children? Up and down, that motion. They are transverse waves. So what is the answer, children? Transverse waves are formed on the surface of water. So now the next one, sound waves are. Sound waves are. What type of waves are sound waves, children? 16th question. Of course, they are longitudinal waves. Sound waves are always longitudinal. So now the next one, 17. The distance between a compression and the next rarefaction. Children, we know that the distance between any two compressions or any two rarefactions is lambda. But the distance between one compression and the immediate next rarefaction is half of that. That is lambda by 2. So what is that, children? Distance between a compression, rarefaction, compression, rarefaction, alternately is formed. The distance between any two compressions is a wavelength lambda, whereas the distance between one compression and the rarefaction is half of that, that is lambda by 2. Well, the next question, the distance between the crest and the next trough in a transverse wave is again, how much is that, children? Lambda by 2. So clearly, crest, trough, crest, trough, crest, trough are formed alternately. The distance between any two crests is given as lambda, whereas the distance between any two trough is also given as lambda. But the distance between one crest and one trough is nothing but half of that, that is lambda by 2. So now moving to the 19th question, children. A stone is thrown in the pond of a water. So this was the example that we are discussing from the beginning. The result is the formation of ease. So whenever a stone is thrown inside the water, what type of waves are produced? Transverse waves are produced. Whenever transverse waves are produced, an alternate crest and trough is being formed. Hence, the correct answer would be crests and troughs. Okay. Well, next question, that is 20th. Which of the following statement is true? Let us look into that. Both light and sound waves are longitudinal. No. We know that light waves are transverse waves, whereas sound waves are longitudinal. So first one is wrong option. So now next one. Both light and sound waves can travel through vacuum. No, light wave can travel through vacuum, but sound waves cannot travel through vacuum. The third one. Both light and sound waves are transverse. Light is a transverse wave, but sound is a longitudinal wave. So third is also wrong. Moving to the fourth one. Sound waves in air are longitudinal. Yes, it is true. Sound waves in air is longitudinal, while the light waves are transverse. Of course, the fourth option is sound waves are longitudinal, whereas light waves are transverse. Now, moving to the next question, that is 21st. If the distance between a crest and the adjoining trough is 20 centimeters, then the wavelength is. Children, I already told you that crest, trough, crest, trough, crest, trough are formed alternatively. The distance between crest and crest is always lambda. Okay, but they have given you that the distance between crest and an adjoining trough is, that is lambda by 2, you have given as 20 centimeters. then the wavelength is, this is your wavelength. If, so let us try to solve the same. Given that, what is given? The distance between a crest and the adjoining trough, that is lambda by 2, is given as 20 centimeters. Then the wavelength lambda is equals to 2 into 20. This is equals to 40 centimeters. So this, you're asked to find the wavelength. So what is the value of wavelength, children? It is found to be 40 centimeters, and hence option number 3 must be true. 40 centimeters. Now the last question, 22nd. Distance between 5th and 15th crest is 20 centimeters. So what is that, children? Crest, trough, crest, trough, crest, trough, like this it is being formed. The distance between the 5th and 15th crest. How many crests are there in total? There are totally 10 crests are there. Okay. So 10 crests indicates your 10 wavelengths. So the distance between 10 wavelengths is equals to 20 centimeters. The distance between a crest and a crest, okay, one wavelength. Again between the crest and a crest, one more wavelength. Between a crest and a crest, one more like that. How many crests are there? 10 crests are there. From 5 to 50, 5th to 15, there are totally 10 crests are there. So the distance between the total 10 crests is 20 centimeters. The distance between one crest to another crest is one wavelength, lambda. So the distance between 5th to 15th means 10 crests are there. So 10 wavelengths are there. So 10 wavelengths, 10 lambda equals to 20 centimeters. So this lambda can be equals to. So we can solve this. Lambda can be equals to, what is that, children? 20 upon 10, or let us try to cancel the same. 0 gets cancelled, and hence the value of lambda is nothing but 2 centimeters. So what is the value of wavelength, children? The wavelength is found to be 2 centimeters, and hence the first option is true. So with this we conclude the concept regarding the classification of waves, and now let us move to the next concept. So until then, keep practicing, children. Take care. Thank you.